All right, so we're talking about polygons. We're starting a whole new section. So first thing we need to do is kind of introduce some new vocabulary that we'll use to talk about polygons. The first and most important is, what is a polygon, right? There's a lot of pieces that go into it, but here are the key ones. The polygon needs to be closed. In other words, there's an inside and there's an outside. It needs to be planar, in other words, flat, two-dimensional, can't be curved into 3 dimensions, like taking a sheet of paper and crumpling it up. That is no longer a polygon, whereas if you lay it flat, that 4-sided sheet of paper that's flat in 2 dimensions is a polygon. It needs to have sides that are straight line segments. There are no curves in your polygon. And then finally, it needs to connect end to end. And this kind of goes back to that it is closed. So there is no like intersecting line with another line, creating 2 separate spaces. That could create multiple polygons. So kind of to zoom in, this star here, that is, if you just look at the outside, a single polygon. But as soon as you draw those into the middle, now, yes, that outside star is a polygon. But if you were to draw it by saying, here's a line, and now I'm going to intersect back over there, well, now all of a sudden you've got this inside area, right? That triangle is a polygon. But then when you cross back over here, now you've got this open area coming in, you've got this open area here, you've got 1, 2, 3 closed off spaces, so this is no longer a single polygon. Okay, so let's go back out here now. So just kind of highlighting what's going on. Notice that, I'm going to get skinnier here. That was nice, it's just that easy to get skinny. Okay, here is one shape with a bunch of zigzag straight lines that ends where I started and closes the shape. So there's an inside and there's an outside. And that's true about all of these. Start at any one corner and goes shoop, 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 shoop with straight lines. Doesn't matter how many times you zig and zag with those straight lines, as long as it goes back to the beginning and closes. This one has 2 separate spaces. So that is 2 separate polygons. Or if you remove this shape in the middle, just kind of erase it with my pink pen, now you would have a single polygon. This one down here is open. This one has a curve. This one has a curve. So these are all kind of a list of things you can't have. So this one open. This one open and kind of intersecting itself here. Again, there is a polygon. Here is a polygon in here. But then what's this leftover part? So this would not be considered a single finished polygon where the start of the line segments come back onto itself. And then this one, same thing. This would be 2 polygons, not 1. So crossing over itself, got 1 triangle polygon, and then now you got 2 polygons. Okay, so now we know what a polygon is. Let's introduce some vocabulary regarding polygons. Okay. Polygons will have some number of sides. Those sides are the straight line segments that form our shape, and they will meet at vertices. So these points where the sides intersect are called singular, a vertex, or multiple vertices. Like this is just a multiple or plural of the same word. Yeah, and your shape will have the same number of sides as it has vertices. The reason you could think about it is, think about if I start at this end and go to this end, here's my ending vertex, side, ending vertex, side, ending vertex, side, ending vertex. And if you always do that, you will get back to the beginning and there's your ending vertex. So each side can be paired with its ending vertex, and that is the exact same number of sides as there are vertices. So that's going to be true of all 2-dimensional shapes. Now we go down to another distinction. I said you could zig and zag as much as you wanted with those straight lines, as long as you end up back at where you started. So you close off a shaded inside and a non-shaded outside. So we have two names we could use, concave and convex. The easy way I think about this is a cave is like a hole in a cliff or something. So here's a cliff, and then here's like a cliff, and here's a cave that goes into it. So I think of a cave as going in. So concave is something that has a cave or an indent in it. So here are a bunch of indents in these shapes. I'll make this larger for ease. Here's an indent in this shape. Here's an indent in this shape. So a concave shape is any shape that has an indent in it, where part of that zigging and zagging goes in towards the center of the shape and then back out, creating an indent or a divot. Whereas you can notice here, all of the corners are popped out, popped out, popped out, popped out. We call that a convex shape. This is similar to mirrors if you've done any physics. A concave lens would look something like that, or concave on both sides. Convex would look something like this, convex on both sides, so sticking out versus sticking in. There is a more rigorous definition that I'll mention in a second, but the easy way I like to think about it is a cave is a hole in or an indent in, and convex has every single corner poking outwards, poking outwards, poking out, out, out. Every single corner poking out versus having indents. The more rigorous definition is a polygon is convex if no line containing the side of the polygon contains a point in the interior. In other words, every line, if I took a side and extended it forever into infinity, it never goes inside the shape. Whereas if there's any indent, like in this second one, this line contains some part of it inside the shape. This line here, if I extend it again, contains some points on the inside. That's a more rigorous mathematical definition. I like to just think about concave as a polygon with an indent or a dent in it. Okay. So now, how do we name polygons? That's the next question. We've got some properties. We could say it has a specific number of sides, specific number of vertices. It is either concave or convex, and in fact, it's either a polygon or not a polygon. But how could we use a name to communicate, like say, its dimensions, its lengths, its type, its angles? So we use two words specifically, or two types of classifications. One, we can use the word regular to mean very specially it is convex, equilateral, and equiangular. In other words, every single angle and side is congruent to every other angle and side. Now that wouldn't be possible if there was an indent, right? Because if I go in and then out, this angle is going to be more than 180 and this one will be less than 180. So the shape has to be convex for it to be true. It has to, every angle has to be popped out. It has to be the same way. So an example of regular would be something like an equilateral triangle. In fact, that is the only regular three-sided figure. A regular four-sided figure would be a square, where all four angles are 90 degrees, all four sides are congruent. A regular pentagon is going to be, oh, look at my art skills. It's not regular looking, but it is a pentagon where all sides are equal or congruent and all angles are congruent. And you can do this with any number of sides. So you can have a regular 6-sided figure, regular 20-sided figure. The more sides, it starts to look basically like a circle. But if it's regular, that means every single side and every single angle in that shape is congruent to one another. All right, and finally, the naming of polygons uses the Latin roots. So in general, we call it gon to end it, and then we use the number of sides, or the common prefix we use. So dodeca means 12, deca is 10, like decimate or decathlon. Decimate, that's an interesting, look that one up, the actual meaning of it. Nona means 9, like a nonagenarian, the 90-year-old. An octa, like an octopus. So an octa is 8 sides. Hepta, that means 7. Hexa means 6. Penta means 5. And then the two ones that don't follow that format are triangle and quadrilateral. Quad meaning 4, actually means square. But so quadrilateral, triangle don't fit that form. Otherwise 5, 6, 7, 8, 9, 10. Those are the ones you should be comfortable with. Otherwise, we just write n-gon. So example, we could just say, hey, this is a 30-gon. And that would mean it is a 30-sided shape. Unless I say it's regular, this could be any 30-sided shape with zigzag, just 30, wonky, whatever, you know. But if I say it's a regular 30-sided figure or regular 30-gon, then it's going to be hard to draw because it would just look like a circle. But you would know that every side is congruent to one another and every angle is congruent to one another. So those are the basic ways in which we classify a polygon. We describe it by its number of sides, whether or not those sides and angles are congruent. And then up here, we can describe its properties. We can say, oh, this has all of its angles or vertices pointed outwards. There's no indent. This is convex. We can count the number of sides or vertices. And then finally, what we're going to jump into next, so I'll just introduce the vocabulary. So first thing we have here is, what is a diagonal? So a diagonal is simply a line segment that connects two non-adjacent vertices. If I pick vertex B, or vertex B, and connect it to, right there, and connect it to an adjacent vertex, we get a side. Adjacent vertex side. If I connect it to a non-adjacent vertex like D or E, I get a diagonal. If this is a convex shape, that diagonal will be inside the figure. If it's, I said concave, if it was convex, whereas if it's concave, some of the diagonals could actually be outside the figure, right? If I connect these two non-adjacent vertices. Okay. The last two we're going to talk about interior, exterior angles. We've actually used this vocabulary earlier. We've dealt with exterior angles of triangles, and mostly we've been using interior angles. But specifically, an interior angle is an angle that is formed on the interior, like if you were closing a polygon and shading the inside. An interior angle is simply the angle formed when two sides meet at a vertex on the inside of the shape. Okay, now you might think then, okay, well then an exterior angle must then be the other part. But that's not actually what we talk about when we talk about an exterior angle. An exterior angle is actually, so we got the, like over here in this pentagon on the right, this is the interior angle. The exterior angle is formed by extending a side outwards and looking at the supplement of the interior angle. This is that exterior angle. And notice it doesn't matter which way you extend the side. You could have extended this other side over here and looked at the exterior angle over here. Still, it's supplementary to the interior angle. And you can see obviously that these two angles are vertical angles, and so they're going to be congruent all the time. So actually, there are in this pentagon not 5, but 10 exterior angles. However, as we move forward, we're going to talk about how many unique exterior angles there are. So we're going to just look at one exterior angle at each vertex. So in general, we'll talk about there actually only being 5 exterior angles when we talk about the sum of the exterior angles. But there are 2 at each vertex. It's just that since they're congruent, we only look at 1. Okay. That's an introduction. What we're going to do right now is just jump onto IXL and practice these vocabulary words a little bit if you stick with me. Otherwise, feel free to jump into your own practice. Okay, here we are in IXL. This is G1 in geometry. How many sides does an octagon have? Well, I know that octa stands for 8, just like an octopus. So this stands for 8. Okay, how many sides does a triangle have? That's an easy one. We've got 3. Okay, is this a regular polygon? So it doesn't tell me how many sides, although I can count it's a triangle here. But we're looking at, is it regular? So regular meaning, are all 3 angles the same? Yes. Are all 3 sides the same? Yes. So yes, this is. Okay, how many sides is a hexa? Hexa means 6. Is this a polygon? Well, actually, it's not for 2 reasons, right? You'll notice that first, it's a curve. That would tell me it's not a polygon, and it's open. So for 2 separate reasons, no, this is not a polygon. Is this shape a regular polygon? I can tell right away it's not going to be, since it's concave. It's got some indents. Notice that this angle is huge, and this angle is teeny. So no concave shape can ever be regular, because those angles could not be the same, one being larger than 180 and one being smaller. Okay, is this a polygon? It's okay that it's concave, that it's got these indents, but it's not okay that it's got a curve. Okay, so no. Is this a polygon? This is similar to that other one. It's curved and not closed. Is this a regular pentagon? Polygon. Again, it can't be regular if it's got any indents in it, because 202 is not the same as 86 degrees. And on the outside, we've also got 23 and 55 not being the same. Is this shape a regular polygon? So regular, I'm looking 140, 40, 140, 140. All the angles match. Look at the sides, 90, 90, 90. They all match. So yes, this is. Is this a polygon? It looks like it's straight lines. It goes from one point all the way around back to the beginning. There is an inside and an outside. It's 2 dimensions. Yes. What kind of polygon is this? Concave or convex? Are there any indents? No. So there's no cave in this. So it's convex. You could also just check all of the vertices are pointed outwards. So yeah, this is convex. Is this a polygon? No, that is curved. We'll do one last one here. Is this a polygon? So that's kind of a tricky question. Is this a polygon? No. It is 2 separate polygons, but it is not a single polygon. All right, I hope you enjoyed this video. Go out and practice on your own, and have a good day.